In the previous unit, we set up our HMS model to get ready for terrain pre-processing. Before we do that, let's change some settings to save our time later. So what we are going to do is we are going to pick the methods that we are going to use in simulating the hydrology of Cedar Creek. So to change these settings, we will go to Tools, Program Settings. So this is where you can change a lot of settings. In our case, the settings that we are going to do are in default. So we want to change the methods that we are going to use for computing losses and transforming the hydrograph. So we want the sub-basin loss to be computed using the SCS curve number method. So we will use the SCS curve number, and this is the reason we created the curve number grid in module 6. So for sub-basin transform method, we will also use the SCS unit hydrograph method. We don't want to calculate recession, so let's go ahead and set sub-basin base flow to none. So no base flow method. And for reach routing, we are going to use Muskingum. So let's change that to Muskingum. And then our input for precipitation is going to be specified hydrograph. So these are the methods that we are going to use. The other thing you will see here is number of cores. So if you are setting up a complicated model that is going to take a lot of computational power and time, in that case you can use all the cores available to you on your machine. So in our case we are setting up a simple model, so we can either use one, but if you want to even expedite the terrain processing, we can use 8 cores. So say OK. So now that our settings are set, let's get started with terrain pre-processing. So to do terrain pre-processing, again we will go to GIS in the top menu. So we use the coordinate system already to set the coordinate system. The next tool that we are going to use is pre-processing. So this is again creating the field DEM similar to what we did in ArcHydro. And this was fast. And what this tool does is it will fill the sinks, and it will also create another raster to show the sinks. So if you right click on the map and say map layers, so earlier we only had the terrain, which is the Cedar DEM. Now we have the field DEM. In HMS this is called sink field, and next we have is sink locations. Since we really do not need sink locations, so I'm going to turn this off, and you can see that after you turn this off you will see the terrain. Save your project. After filling sinks, if you remember, we do the flow direction and flow accumulation. So again, in HMS, this functionality is available under GIS. So in GIS, after we finish pre-processing, the next option we have is pre-process drainage. So pre-process drainage basically means establish the flow direction and calculate flow accumulation. So we will click on that. One thing you will notice is that there is no interface to ask for inputs and outputs. So this is a step-by-step process. So as we move along, HMS knows all the previous inputs, and it will use those inputs to do the processing for a particular tool. So again, we can right click and see what new layers are added to the map or desktop. So if you right click map layers, so you can see now we have flow direction, we have flow accumulation. If I uncheck flow accumulation, you will see the flow direction grid on the map, and flow accumulation, if you zoom in, you will see that the flow accumulation is higher along the streams. So I'll zoom out. After flow direction and flow accumulation, we will delineate streams. So let's close the map layers window, go to GIS, identify streams. Now to delineate streams, it will work on the flow accumulation grid, and we specify the stream area threshold. So if you remember, in all the other previous modules, we have used an area of 25 square kilometer. So we will use the same area and say OK. And the stream raster will be added to the map. In order to see that, we can uncheck some other layers. So to do that, we will right click, we'll go to map layers. So let's uncheck flow accumulation, flow direction, sink fill, and terrain. So I'm not going to close the map layer window, so just to show you the stream that was delineated. So if you remember, in ArcHydro, we first delineate the streams and then we segment them, and you can see in HMS we already have the segments created. So the process is little faster and easier in HMS. Once we have the stream, we are now ready to delineate the watershed boundary. So to do that, we only need the stream network. If you want, you can also turn the terrain on. So we have terrain and streams, and we are going to use the Cedar Creek outlet as our outlet point, and that outlet is, let me zoom out. So we are going to use this area as our outlet. So I'm going to zoom in again. So you see this section here, and there is a sort of step here. So I'm just going to put my outlet here in this part. So to define the outlet, we will use the breakpoint creation tool. So click on this tool that you see here as red pointer, and I'll click here, and we will give some name to this. So we will just call it as Cedar outlet, and description, if you want, outlet say create, and you will see that red point created at this location. So once we have the outlet, now we can delineate boundary for this outlet. So to delineate the watershed boundary, we will go to GIS and say delineate elements. Subbasin prefix. So if you have used HMS before, you may have seen the subbasin starts with W, reaches start with R. If you want, we can specify those here. If we keep them blank, our subbasins will be called subbasins and our reaches will be called reaches. So we are going to just leave this blank to keep it simple and say delineate. And after a few seconds, you will see that all the subbasins are delineated. We now have a basin model created for Cedar Creek in HMS. So let's go ahead and save our project. In the next unit, we will explore some of these subbasins in detail, and how many subbasins we have, how many reaches we have, and we will also merge some of the smaller subbasins in the next unit. So save your AHKMS project and we'll do the further processing in the next unit.